Okay, so now that we have learned about how to describe data graphically with column charts, pie charts, bar charts, histograms for quantitative data, stem and leaf plots, let's turn next to numerical descriptive statistics. And when it comes to numerical descriptive statistics, we typically distinguish between measures of central tendency. Those are typically the mean, could be the arithmetic mean, geometric mean, then the median, the mode, and generally percentiles. So those are measures of central tendency and location. And when it comes to measures of dispersion, those are the standard deviation and the variance and the range. And then we also have some combinations of measures of dispersion with measures of central tendency, like the coefficient of variation. And so let's begin with measures of central tendency and location. But before I do so, I want to say a few words about notational issues. Because in statistics, the whole purpose of statistics is to make inferences from a sample about things in the population. So we try to infer from a sample what's going on in a population. So whenever we deal with a sample and we calculate, let's say, the sample mean or the sample standard deviation or the sample range, then we call that a statistic. But if I know the population mean and the population variance and standard deviation, if those are known, those are said to be population parameters. So it is important to distinguish between population parameters and sample statistics. So the mean of a population, that's a parameter, but the mean of a sample from the population, that would be a statistic. And numerical descriptive statistics for population and samples, they are often technically or computationally identical. It's not always the case, but often. But what's important at this point, what I like to highlight is that we use different symbols for population parameters and sample statistics. So Greek letters are typically reserved for population parameters and Latin letters for sample statistics. So for example, when you see the Greek letter mu, that will be the mean, but when you see something like x bar, that would be the sample mean. Or the sigma is typically used for the population standard deviation, but the small s for the sample standard deviation. So again, Greek letters are typically reserved for population parameters, Latin letters for sample statistics. And it is moreover quite common to denote population observations in capital letters and sample observations in lowercase letters. So to make a long story short, in samples we work with statistics, and in populations we work with parameters, and we have different notations for those as well. And as we practice over the next couple of videos, I think it will easily become muscle memory. Okay, let's just stop here with that brief introduction, and beginning with the next video, let's talk about the first measure of central tendency, which is the mean.